This video is to show the ECM Lambda 5220 analyzer and how to set it up for a demonstration. This is the analyzer set up here. There's an analyzer display head, a Lambda CAN P module, and the associated cabling. This blue-gray colored cable is the internal ECM EIB bus that is used to communicate between the Lambda CAN and the display head. The CAN bus has a termination resistor shown here on either side. The power comes from this AC/DC supply plugged in the wall here. When it's plugged in and powered on, there's a green light visible on the top of the power brick. The analyzer is shown here powered up with the sensor cabling and sensor ear. It's powered up and running right now. So the analyzer can be turned on using the power button shown here, and with the display active, you can also see a green power LED on the face of the Lambda CAN P module there. If there is an error or other issues, this will either flash in either green or red to indicate issues. Okay, to power up the display head, you hit the PWR or power button on the bottom. As it powers up, you'll see various parameters displayed on the screen: product code and version, the calibration date, the module that it's associated with, and finally this is the startup countdown to indicate that the sensor is in the heating up phase right now. As soon as the sensor is available to be read information from, the parameters will become live. As you can see right now, these LEDs indicate which parameter is shown on the upper and lower display. The upper display is lambda, indicated by the red LED powered up here, and on the bottom display, the green LED is shown as O2 on the bottom display. As the sensor is hanging in air, it's ambient oxygen, approximately 20.6% oxygen in air. To change the parameters that are shown on the upper and lower display from this measurement mode, you can push the up and down arrows. If you push the down arrow, the upper display now changes to air-fuel ratio. Keep scrolling down, it goes to phi, or inverse of lambda. Percentage O2, same top to bottom. Scrolling back up, you can go back up to lambda. To change the lower display, press enter, and up or down. This is a P5, which is a programmable parameter. Go up, back to percentage O2. The next setup is how to change the analog outputs for the analyzer, which is important if you're using analog outputs to go to a data acquisition system. To go into the menu mode, you press the system button, and a menu pops up. You can scroll down to go through the various settings here. Many of these are described, all in fact are described in the manual, and we'll go through a few different ones. Most important one for getting data out is the analog output setup. The analog output setup, A out, can be used to set up all 6 analog outputs on the back of the analyzer, shown here. 1, 2, 3, 4, 5, 6. Here we're connected to analog output 3 to this multimeter here. So if we hit enter, we go into the submenu. A1 is analog output 1. Let's go and look at the setup for analog output 3, which we're connected to. We scroll down, analog output 3, hit enter. Now it tells us which parameter is being output on the analog output, and it's percentage O2. We can scroll up or down from a variety of parameters available. We'll stick with O2. Now this 0 volt, 5 volt is asking us to set up the 0 and 5 volt range of the analog output is 0 to 5 volt output. We hit enter. It's asking for the 0 volt limit. At 0 volt, the O2 parameter is going to be minus 25% O2. If this is what we want, we can hit enter, and we will scroll through each of the characters in the parameter to adjust all of these. If we like what we see, we can keep hitting enter to go through. It'll then ask us for the 5-volt range. 5 volt again is 25. If we want to adjust this, we can simply change this up or down. Let's say we want to change it to 30. We can go up to 3, down to 30. We can adjust each of the decimal places as well. Finally, we're out. If we want to go back to the original setting, we can go back in easily to A out 3, 0 volt, 5 volt, 0 volt setting we can be happy with. If we want to get rid of the negative, we can just keep adjusting to get rid of that as well. 5 volt, we want to go back. Notice the decimal place is only valid in one location, so this can be adjusted to move any number of significant digits whenever required. And notice the analog output on the multimeter changes accordingly to our 20.56 output. To further set up the analog outputs to determine if you're getting good readings to your data acquisition system, there's also a test mode which can output 1 volt or 4 volts on all of the analog outputs to determine if the data acquisition system is reading the analog output correctly. By this, you can go back into the measurement mode and press Sys and scroll down through all of the menus down to Configure on the lower display. Just keep pressing down to get there. Hit Enter and scroll down to 1 volt, 4 volt, 1V, 4V. Press Enter. When we hit 1 volt, exactly 1 volt is output on the analog output. When we're at 4 volts, exactly 4 volts is output on the analog output. This is very good for debugging purposes. If we hit enter, we return back to the mode. To get out of the menu mode, all you have to do is press the system button. Now, setting this analyzer up in the dyno room is quite straightforward. All that has to be done is the display head can be mounted usually in the control room, where the operator is able to use the front panel menu. Typically the lambda CAN module itself will be in the dyno very near to the engine, where the sensor can be routed, the sensor cabling can be routed to near the engine. So when powering the unit up in the engine, the important things to note are to make sure that always the analyzer is running, so that the sensor is hot anytime the engine is running. This avoids contamination issues with the sensor and maintains its calibration much better. The sensor can be damaged if it's used in an engine without being powered on. So always make sure the display head is powered up anytime the sensor is in an engine. The sensor you also want to mount into the exhaust pipe so it is near vertical, anywhere from this position to this position. If it is upside down, then condensing water in the tailpipe of the engine can crack the sensor and damage it, and this is catastrophic to the sensor. It will fail. So make sure it's always mounted near vertically. The next option is the pressure compensation option. If the 5220 analyzer is used in a lean burn application for diesels in particular, this is very important, as changes in back pressure where the sensor is mounted affect the calibration of the sensor, and so must be compensated for. To install that, you need a pressure compensation kit, and what you need to do is change the cabling from the sensor to the engine. So we'll do this with by first powering down the analyzer. The green light on the module will go off, indicating it's off. Disconnect the sensor here. We add this Y cable, which has a breakout for a pressure sensor as well as the oxygen sensor. We plug that into the module. We can plug the oxygen sensor back in. Then we have an extension cable for the pressure transducer. here, so we can mount it in the same place as the oxygen sensor. Finally, we have the pressure sensor itself with the connector, which contains a calibration chip, which contains the calibration information for this pressure transducer. Put that here and just read ambient oxygen. We connect all this. Finally, power the analyzer back up. It will go through the startup procedure. The oxygen sensor is warming up. And begins to show oxygen readings as well as lambda readings. Notice the oxygen reading did not change significantly because we were measuring ambient air, and this sensor is experiencing the same total pressure as it was previously. When mounting the pressure sensor in the engine, the oxygen sensor boss should be mounted within approximately 10 centimeters of the pressure sensor boss. And to mount the pressure sensor in the engine, we use this tubing assembly. This 1/4 inch ISO thread fitting is mounted in the tailpipe near the oxygen sensor. This tubing assembly has a stainless steel tube to reduce heat and a PFA section to reduce vibration. The pressure transducer is installed here, and this is mounted in the engine near the oxygen sensor. If we'd like to see what the pressure is, we're able to view this on the display head. Okay, so in the measurement mode of the analyzer, we hit the sys button to get to the menu mode. If we want to look at the pressure parameter, we can go through these P1, 2, 3, 4, 5, 6, 7, 8. These are the programmable parameters of information you can view on the 5220 analyzer. If we scroll down to display, we scroll down to P2, is actually P for pressure. If we go back by pressing the sys button to the measurement mode, we scroll down to P2. This is the pressure in kilopascals, 101.1 kilopascals here today. If you change the pressure, you can see the pressure reading changes. The oxygen reading is actually compensated for that as well. This shows you the effect of changing pressure on the oxygen reading itself. We scroll back up and get back to lambda. These readings are all automatically compensated for the changes in pressure using this system. And that's how you use the Lambda 5220 analyzer from ECM.